Okay guys, so here's an example of an application where we're going to use integration to find a particular function. Okay, so now remember there are lots of applications where we're going to need to find certain functions, and the way we're going to do it is using integration. So this is going to be one of them. So this is a price demand type of problem. So we're looking for finding the price demand function, okay, for a particular brand of toothpaste. So it says find the price demand equation for a particular brand of toothpaste at a supermarket when the demand is 50 tubes per week at $2.35. Okay, so that is the demand. So when the price of the toothpaste is $2.35, they're going to sell $50, basically based on their research and based on their data. They are going to sell 50 tubes per week at that price. Okay. Now, given that the marginal price demand function, which is represented by the derivative of the price demand function, okay, that's how we get marginal cost, marginal. That's what marginal means. Okay, instantaneous, if you will. So we want the marginal. So this would be the price, the demand function, instantaneous, if you will. So the marginal price demand function for the X number of tubes per week is given by this exponential function. Okay, so now, so we need two things. There's two things. First thing we want is we want to find the price demand function. So we're going to have to integrate this thing to find it. Okay, so let's do that. So let's integrate both sides, right? So if we integrate both sides, then we're going to get P of X, which is our demand function, okay? Price demand function, if you will. And what are we going to have to do over here? Well, we're going to integrate this thing, and we don't have to use U substitution. Use the rule for exponentials. So this is going to be negative 0.015, okay? And we integrate this by using the rule. So we're going to take the derivative of this thing, right? Oh, hold on. dx. I was forgetting something. So in this case here, again, actually we do want to use U substitution. It'll make it easier. So let's just do a U substitution. The more you do these, you'll find that you won't need to use a U substitution when it comes to something like this because you'll see the pattern. But let's do the U substitution. So in this case here, I'm going to let U equal the exponent, right? So it's going to be negative 0.01x, okay? And then du is going to equal negative 0.01 dx, right? And so if I do this, then what I'm going to end up having is my negative 0.015. Oh, hold on a second. I want to divide by negative. I want to divide both sides by that. So let's do, so this will be so let's just do that. Okay? So I'm dividing both sides by negative 0.01. And so now what I'm going to end up doing is I'm going to have this divided by negative 0.01, right? And then the integral is going to be e to the u du. Okay, so far so good. That should make sense. Okay. Now what's going to happen is this is going to become what? Well, in this case, it's just going to be 1.5 in front, because if you simplify the fraction, it becomes positive 1.5, so it'll be 1.5 times the integral of this thing, which the integral of e to the u is just e to the u plus c. And so our function is going to end up being what? Well, we got to put back in for x. So x is, where is it? Our u is negative 0.01x. So this becomes 1.5 e to the negative 0.01x plus the constant of integration. Okay. Now, again, pause the video, make sure you understand that that's the function. Okay? Now, here's the thing. We don't know what c is. So we have to use the information given to us in the problem to help us solve for c. So what information do they tell us? Well, they tell us that the demand is 50 tubes per week when the price is $2.35 per tube. Well, what we can do is we can use this equation now to solve for c. Okay, so let's do that. So x is 50 tubes, and p of x is $2.35. So let's use that. So we just solved for p of x, so p of x equals 1.5 e to the negative 0.01x plus c. And now what we're going to do is we're going to plug in for x and p of x, right? So p of x is 235, and x is 50. Now in this case you have to use your calculator. Okay? So in this case I'm going to solve for c. So let's solve for c. So c equals 2.35 minus 1.5 e to the 0.05. So this will be negative 0.2. No, it's going to be it's going to be 0.5. Okay, oops. Right, so just think about it. 100 times this would be negative 1. So half of that is negative 0.5, so that's right. So now all we have to do is get our calculator and plug it in. And then we find that c equals 1.44. And now we've got our final equation, which is p of x equals 1.5 e to the negative 0.01x plus 1.44. And so that's the first part. So we have our demand, our price demand function. So there it is. So now the next thing they ask is, okay, well, what if they want to sell 100 tubes, right? So price demand function, right? So price affects demand. Demand affects price. So if they want to sell, if they start selling 100 tubes per week, Now, if they start selling 100 tubes per week at $2.35, I probably wouldn't change anything. But if they're looking at research and they're looking at their demand band curve and they say, okay, well, what price, if we do want to sell 100 tubes, what price should we set it at? Well, let's find out. So we're going to say P of X equals 1.5 e to the negative 0.01 times 100 and then plus 1.44, right? By the way, if they don't sell any tubes per week, they're saying that this is like the starting price for the tube, $1.44, okay? Again, interpretation may not be meaningful, but nonetheless. Okay, so what does this mean? Well, if I plug and chug, use my calculator and plug it into this equation, or just plug it in the calculator and solve for this, I get approximately $1.99. And so that's what they should price the tubes if they want to sell 100 tubes per week at that supermarket. And that's it. So again, we'll do another example in a moment. So have a great day.